Hey everybody, this is Alex Merced from alexmercedcoder.com. And while I've done a lot of videos on destructuring, like literally my last video was on destructuring, one thing I realized I haven't talked about is there's two other ways of packaging information in JavaScript. And I've never really discussed whether you can or how would you go about destructuring them. And that is maps and sets. Okay, so sets are essentially just kind of like arrays. Except you can't really access their individual properties. But the reason you use an array, a set, is because you don't want duplicates. So just to kind of show you sort of the practical reason you would have a set is I have an array. My array, so const my array equals 1 1 1 2 2 2 3 3 3 3 3, and I don't want any duplicates. I just want 1 2 3. So then what I can do is I can put it into a set. Okay. And then I'll just be like new set. And then I'll just pass in my array. And then what I would do is console.log my set. And let's just see what we get. Save. Okay, and so you get a set 1 2 3. But notice, see, it's not an array because it doesn't have the square brackets. So if I did want to turn it back into an array, because this is a typical technique to just remove all the duplicates out of an array, I would do something like this. Const my r, so, well, const my r2 equals new, oh no, a new array where we spread my set. So that just takes a set. We use a spread operator to spread it out inside the array, so that way, essentially, because what the spread operator does, it just, instead of putting the set in the array, we're going to break apart the set and make it just 1 2 3 inside the array. So that way you get this. So I'll show you both ways so you can see the difference. So this is with me using the spread operator. So these, nope, I didn't change what's in here. My R2. Save. Okay. So you see, I just get my array with 1 2 3. So I have all the duplicates removed. Now, if I don't use the spread operator and I just say, hey, my array equals my set, like this, watch what happens. See, now I have an array with the actual set in it. So the spread operator helps spread it out. Basically takes everything out of the collection and puts it as if I were just putting the individual items into the array brackets, which is nice. Yay. Okay, so that's a set. But what if I want to destructure a set? So I have my set here, and I want to destructure the set into variables 1, 2, and 3. Okay? So normally what I would do is, if it was an array, I would just put my array brackets, and I would just say, hey, 1, 2, 3. Okay? That would be all fine and good. But I can't do the set directly. I can't destructure the set directly, because let's watch what happens. If I try to destructure my set directly, it doesn't actually have the ability to be destructured. So, let's give it a shot. Yep, see, it throws an error. Okay, let's see what it says. My R2 is, oh, well, that error doesn't have anything to do with that. So let's do this. 1, 2, 3. Let's see, will there be an error, or will this actually work? Nope. What is the error? Nope, I need a 1, 2, 3. Missing parentheses after argument list. Oh, here's where I'm missing a comma. Okay, so these are just basic syntax errors. So let's see if there's actually an error when I try to destructure the set. No, actually you can. There it works. Okay, destructuring a set works just like destructuring an array. So I could literally just do that. Okay, so basically the first item, and that makes sense because a set is an iterable. So you should be able to destructure it like any iterable. Okay, so that makes sense. So the first item will go into 1, the next item will go into 2, the second item will go into 3. So you can destructure sets just like you would destructure an array. That makes sense. Okay, now let's talk about a map. So the way a map works is I would do like const my map equals a new map. Okay. Then what I have to do is actually give it some entries. So my map dot set, we'll say name Alex, my map dot set age 34. Okay, and first just so a map is just another key value pair, kind of like an object. The only difference is that with a map versus an object is that you can literally use anything as a key. So first let me just console log my map so you can see what it looks like when it gets logged. Okay, so map, name Alex, age 34. But the cool thing is I don't even have to have, you know, the string name as a key. The key doesn't have to be a string. I could just make it a number. So I could be like 1 is the key, 2 is the key, and then that would work. Okay, I couldn't do that with an object. There are many reasons I could find that you'd probably want to do that, but there might be a situation where you want to hide things behind a number, or maybe make a boolean a key for some reason. So that's a thing. Cool. Now that we have our map, let's try destructuring it. Okay, so let's just see what happens if I try to destructure it using an object destructuring. So const, which it shouldn't work because it's not an object. So if I try to do this, name age, this should probably not work. My map. Oh, that's the other big difference with maps versus using an object. Maps are iterable, which means you can iterate them. I could use a for loop over a map. Okay, a for of loop versus a for in loop, which is the only for loop that works with an object. Cool. So let's try that out. That probably should not work because that particular syntax really is strictly used for objects. Yep, throws an error. Okay, so my map is not, oh, and then why did I put a function thing there? So over my map, let's try that again. And see, it tries to, but it doesn't get anything because the way object destructuring works, everything in JavaScript is an object, so it's not going to fail. It's going to be like, oh, my map's an object like everything else in JavaScript, but it's going to look for properties. And there is no property by the name of name. We think there is because when I console log the map, I see there's a key and a value pair, but they're not in this. But they're not a key value pair in the same way that an object has key value pairs. Their key value pairs are known as properties. So in this case, this syntax doesn't work. But now that I think about it, this should work because it is an iterable. I should be able to do this. I want to store the first key value pair in a variable called name, and then the second key value pair in a variable called age. And see, I'm doing it as an array. And this array destructuring syntax with a square bracket should work over any iterable. Okay, and really the main iterables are just basically arrays, maps, and sets. Okay, I mean, I think there might be a few others that are really sort of deeply nested into JavaScript. And there might be custom iterators. Okay, you can make your own iterable if you need to. So some libraries do have custom iterables, which means you should be able to use the syntax with them. But basically the idea is that it's going to take whatever the first thing in the iteration cycle of the thing on the right hand is and put it in the first variable, and then take the second thing, etc. So arrays iterate, sets iterate, maps iterate. Although let's see what you get. I have an idea of what you're going to get, but I'm not 100% sure. I think if I'm right, I think you're just going to get an array with like name and then the string and then another array in age. Let's just see. Yep, that's what I thought. Okay, because basically really what's going on in a map, the way it stores the key value pairs. So really under the hood, you have an array of arrays. So technically, this is what the map actually is. It's name Alex age 34. So essentially, when you use set, all it's really doing is pushing another 2-item array into this bigger array. And if you use the get function on a map, all it's doing is searching the first item in each subarray to see which one matches the key you set. So I mean, that's technically what's going on under the hood. So in that case, basically what happens, this is the first property, so that gets stored in name. And this is the second property, so that gets stored in age. So that works. You can do that. Another thing you can do is you could do, if you want to do object destructuring, so you want to do this, name, age, and you really want to do that, you can do object dot from entries my map. And if you pass in the map and from entries, it'll then turn it into a normal object. Save. So this will return an object with a property called name that equals Alex and a property called age that equals 34, and then I can destructure that object like this. So let's just test that out. And yeah, see, that works. So that's another way you can kind of get to the same place. But the biggest takeaway is, again, when it comes to destructuring maps and sets, you can use array destructuring syntax, meaning the square brackets, because they're iterables, and that square bracket syntax can be used over any iterable in JavaScript. So if someone makes a custom iterable, which how you do that is really complicated. You have to worry about this whole next function and this symbol.iterator thing and all this stuff. But if that exists in a library, you can then use that iterable and use this that array destructuring syntax. While the object destructuring syntax with the curly brackets can only be used on objects. So anything else other than an object you would want to use it on, you'd have to turn into an object. And it's basically fishing for their properties. Okay? Like, let's actually do something really funky, just to kind of illustrate this. Because again, one is looking for, again, curly brackets, square brackets, is going through the iteration cycle. That's how it assigns the variable names. The object curly bracket syntax is looking for pattern, a property name matches. So you could technically just use object destructuring on an array, and I'll show you how. Const my r. Let me just do something really weird. Okay, my array equals 1, 2, 3. Then we're going to say my array, because again, arrays are an object like anything else. You can actually assign properties to it. So I can say my array dot 4 equals 4. My array dot 5 equals 5. Not that you would typically do something like this. It's kind of odd. I can't think of many situations where I want to store, unless the array means something specifically and you want to store those extra pieces of information in there. But then I can do this. My console log my r. Let's just so you can see that the properties are in there. My r, save. And see, 1, 2, 3, 4, 5. Okay, I know that's probably really odd. You're like, what's this? What's going on? Because again, the array is an object, so it has that sort of keyless iterating values built into it because it's built as an iterator. But everything in the JavaScript is an object, so literally any piece of data can be assigned properties. Okay. Everything except I think basic primitives. So I couldn't assign like a number, string. Maybe you could assign strings a property. That's something. Yes, you can. You can. Strings have a prototype. So really, it's just booleans in numbers that can't. I don't think have a prototype, so those can't be assigned properties. Okay. So console log my r. So you saw that there. So now let's try destructuring it. So even though this is an array, I'm going to use object destructuring to get those two properties. So I'm going to use an object notation. 5. The two properties are named 4 and 5. And again, that's going to equal my r. So even though there's an array in there, what this does, object destructuring, at the end of the day, is really just looking to see, does this piece of data have a property using dot notation that's called 4 and taking it. This is taking a property that looks 5 and takes it. So in this case, if I do 4, 5, save. Okay, and there you go, it works. So you could do that. Now just one final test. Let's see if I could assign a number of property. My val equals 1. Okay, and let's do my val dot 4. My val dot 4 equals 4. And then let's just console log my val. I'm not sure if I can do that. I don't think I can. Okay, so there's my val, but where does my val.4 go? Does that still exist? Save. Let's console log it. Does it actually store that? Undefined. Yeah. So you can't store a property on a primitive. Let's see if I do. If I make this a Boolean, would that still hold true? So yeah. And then if I did it as a string, would that hold true? Save. Okay, not even on a string. Although, let me think about that. Why wouldn't it be on a string? I guess because the string itself is not an object. It has a prototype, and I can assign it to the prototype, but itself is not an object in the same way that other things were an object. So okay. So this is why it's important to like experiment and try to like stretch the depths of your imagination, because you can kind of discover where certain lines exist. Okay. So what I could do is I could do this. I could do string dot. Actually, I think it's string dot prototype dot 4 equals 4. I'm pretty sure I can do this. So now, if I were to try to print the property 4 from my val, then it should work because of the prototype. Yep, so that works, which is a separate object. I'm not assigning it to my val, but to the prototype of all strings, which is an object, but the string itself is not an object. So that might be a kind of a hard thing to appreciate at the moment. So I would go back and watch some of my videos on prototypes, but yeah, so that's a neat trick. But I don't think numbers and booleans have a prototype. Pretty sure they don't. So we won't stretch this and try to break JavaScript any more than we already have. So hopefully you found this interesting, and hopefully opens up your doors to sort of like, again, how does the destructuring syntax work? Actually, like, it just literally opened up for me a little bit while making this video. The whole how how it works specifically just kind of clicked under the hood. So this was definitely a worthwhile video, and I hope you guys enjoyed it. Have a great day and enjoy.